Advanced Math Lesson 11, Circles, Properties of Circles, and the Quadratic Formula. We're going to focus on properties of circles and how they relate to chords, interior angles, secants, etc. First example we'll be starting with is 1.11 right here, and we've already copied this onto our work paper. So on this problem, they give us this circle with these inscribed chords and interior angles, and they tell us to find the value of x and y. Now the main thing to notice here, we're looking for interior angles. The main ones, if I can trace these, be angle PAR, PBR, ARB, and APB. Those are the four angles we're dealing with. The reason why they matter is because we know, like for example, with if we just look at it like angle R or angle P and angle R, we see that this angle subtends the same chord or same arc as this angle, as angle P, and we know that interior angles that subtend the same arc are equal to each other. So we can write an equation right here. Since these two angles make the same section or arc from A to B, they cut off the exact same section. We know those angles are equal, so we can write an equation. Since we know this is 46 degrees, we know that 46 degrees is going to equal x plus 10 degrees. From there, solving for x is very easy. We just subtract 10 from each side, and we get 36 equals x. So we've already solved one of them. Next, we need to solve for b, and then we'll notice that if we look at angle B and angle A, they both subtend the same arc, PR. So this angle cuts off this arc, this angle cuts off the same arc. So those angles are also equal, so we can do the same thing. We'll say that 30 is equal, that's an ugly 30, let's start over. Say 30 equals y plus 20, right there. Subtract 20 from each side, and then we get 10 equals y. So our values, x equal 36 and y equals 10. Next problem. And we're dealing with more interior angles. So this is our problem, and we need to find the three unknowns of x, y, and z. Now, to solve this one, we need to remember that with an interior angle, that is one that has its vertex and endpoints on the outside edges of the circle, like this one right here, the arc that it creates is double the length of the angle. So this 80-degree angle creates this giant arc that stretches from z all the way to 50, and this giant arc is twice as big as this angle. So if this is 80, this entire arc is 160. So in order to find z, all I have to do is take 160 minus 50, and I'm left with z. So now I know that z is equal to 110 degrees. So that's one of the missing parts right there, right off the bat. Now I got to try to figure out y and x. So in order to do that, I got to start getting the rest of the pieces of these degrees around the circle. Now I know that this angle, 75, if I go across the arc that the 75-degree angle is going to make, is going to be 150. This half is 50, so this arc must be 50. Or I'm sorry, 100. So that's 100 degrees. Now I got to find the last arc. So again, this is 110 up here. We've got 100 and then 50 over here. Now, there's one easy way you can do this. I can remember that there's 360 degrees in a circle. Right now, I've got 110 and 50 is 160, plus another 100 is 260. So if 360 minus 260, this is 100 over here. Now, what I've gained by solving all these outside pieces is now I can figure out the interior pieces. All right. So let's find out the value of angle x. X subtends this giant arc. If we add these two arcs together, 100 plus 100 is 200. 200 divided by 2 is 100. So x equals 100. So again, we're adding these two arcs together to make the arc that x creates, which is 200. 200 divided by 1, or divided by 2, 100. Last one, y. So we find the arcs that y creates. Y creates the 100-degree arc and the 100. In direct proportion to each other. So what we could say is, if we were to cut this down the middle, we could say that the left side of 15 to 5 to x plus 5 is the same as 20 to x plus 10. It's just another ratio problem. So what we do is we take the 15, we put it over x plus 5, and we're going to put an equal sign. That's going to equal 20 over x plus 10. Oops, not 2, 10. 10. And then again, to solve this proportion, we would cross multiply. That's what they mean by the product of the pieces. When we cross multiply, we get 15 times x plus 10 equals 20 times x plus 5. And again, don't forget to put these polynomials in parentheses. From here, we would distribute. We have 15x plus 150. That equals 20. This one distributes as well. We get 20x plus 100. Now we need to solve for x, so we'll go ahead and start moving things. I'll subtract 15 from each side to move them, and then I'll subtract 100 from each side to get everything on the same side. So 150 minus 100 gives me 50. 20x minus 15x leaves me with 5x. Divide each side by 5, and I get x equals 10. And now I have my value of x. So again, it's just a proportion. Take the left over the left equals the right over the right, and then cross multiply to solve. Really simple. Next, we're going to go into complete the square. All right. Now, sorry, not complete the square. Quadratic formula. So quadratic formula was found by using complete the square on a quadratic equation using letters instead of whole numbers. So this equation you're going to have to memorize. It's read negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll rewrite this really quick. That line's kind of bugging me. Wow. Okay. So there it is. Now it looks a lot better. Negative b plus or minus square root of b squared minus 4ac all over 2a. You need to memorize this. You're not going to. That's the end of it. You got to memorize it. We're going to use this equation a lot in dealing with our quadratic equations. It's going to be a tested thing. Go ahead and memorize it. Write it down, memorize it. I'll probably put it on a couple of quizzes too, just for good measure. Now to solve this, all we have to do is take any quadratic equation. Let's say we have 3x squared minus 2x plus 5. Right. So this is our quadratic. All we have to do is think of the coefficient of each number as a, b, and c. So one way to think of it is that all quadratic equations follow the form of ax squared plus bx plus c. So using that logic, in this case, the a would be 3. So we can say a equals 3. Negative 2, and yes, the negative sign goes with it, is going to be equal to b. b equals negative 2. All right, and then the last one, positive 5, is going to equal to c. c equals positive 5. Now that we've gathered that information, we're going to take all that information, we're going to plug it into this equation. We're going to use our plug-in method. So instead of writing negative b, I'm going to write negative parentheses negative 2, because we always substitute inside of parentheses. So negative, negative 2, or negative b. Then we put our plus or minus square root b squared, or negative 2 squared, minus 4 times parentheses a, which is 3, and then c, which is 5. Now, put all of that over 2 times a. All right, so this is our plug-in method. We substitute. Now all we have to do is simplify this and we have our answer. So we'll go ahead and start with parentheses and exponents. I usually like to start inside this radical because it's the most complex part. So I can take this -2 squared, and that's going to become the square root of 4, right, minus, let's see here, 3 times 5 is 15, and then we've got -4 times 15 is going to give me -60. So that's going to be 4 minus 60, right? And then, let's see here, 4 minus 60 is going to equal -56, right? Square root of -56. That can't be so we have to change that to square root 56i to get rid of the negative. Okay, so all this is just going to replace all of that. And then in the numerator, we still have -2. That's just going to become +2. So right now in the numerator, we have +2 plus or minus square root of 56i all over 2a, which 2 times 3 is 6. And that is our answer. That's how quadratic formula works. Just take the information, plug it in, simplify. Really easy.